and he'll tell you about it.
Thank you. Uh, so, I want to take you for a journey today and talk about what we did. Uh, but first, let me introduce myself. I'm Szymon. I work for PandaDoc, that you're probably not familiar with, but a couple of words about that later. I've been 3 years with the company, but working on AI only for something like half a year. I'm a big fan of Python. I do most of my work in Python, but since introduction of tools like Cursor or Cloud Code, I can work with anything, and so do you. And fun little fact, I fixed and collect vintage typewriters. So if you're into that, talk about it after this meeting. So let's introduce PandaDoc. We are a company about documents, especially everything about documents. All in one solution. Document automation, creation, signing, exporting, whatever. We target small to medium businesses, and we have quite a few customers. So dare I say we are successful. And our goal is to just make the world easier for people who have to handle documents, because often the procedures around them are not that simple, and we want to change that. So what do we offer? We have a platform that allows you to create, sign, change, send documents. We have a lot of integrations. Ask our sales reps about it. And the cornerstone of our business, of our product, is the editor itself. So the document you can see in the editor, right? You can edit it, you can get interactive, you can do a lot of things. Even when you only show the document to one of your prospects, it's still in the editor, even though it's not really editing. And as a part of how we set up processes for our clients, we have a thing called templates, which are pretty much blueprints for documents. Because if you ever worked with documents, it's a repetitive job. You have to have some kind of blueprint that will allow some kind of customization per recipient, per something. But it's easier to start with something than with nothing. It works the same way as document, but has more varied features like variables, fields, roles. The blocks are constant, but also a bit change. And how we get the documents or the templates into our system, because we don't live in a void, right? If someone comes to us, he probably already have some documents, maybe Word documents, maybe PDF. So we have an import pipeline. And there's a lot of different formats that can happen, right? Word, docx files, PDFs, scanned PDFs, raw files. And how do you get them into the system? Depends. We have 2 or 3 different approaches. Docx files, we have like programmatic import that will turn editable document into editable PandaDoc document. So you can continue your experience. It works not really great, because as in the bottom you can see, the specification for the format is crazy. You can express list in 10 different ways, and in PandaDoc you can express it only in one way. So we don't handle all edge cases, and we'll never will. So it's working, it's not great. We wanted to improve it. Another pipeline, PDFs. A lot of people have them. When you drop it to PandaDoc, you get the same exact thing as you dropped in, but you cannot edit it. It's just read-only, almost like an image. You can use some of the features like fields, but it's also not great experience. Same with scan docs, read-only import, and that's a problem. We wanted to change that. And how we can do it? First, we hired a team of people who would do it manually. They are helping our biggest customers create their templates, but this is not scalable, right? And the results are okay, but it depends on the person who is doing the conversion. And we thought, can we use LLM for that? Like, LLM can look at a document, understand how it's structured, understand instructions, and output some kind of format that we can maybe understand as a PandaDoc company. And it turns out, yeah, that's exactly what we can do. So we started prototyping. We vibe coded this tool we called DocMorph that allowed us to quickly iterate. We tried different providers like Claude with 3.5, 3.0, smaller, bigger models, GPT models, different prompts, different intermediate formats. Thanks to existing tools like Cursor and Cloud Code, we created this and we adjusted it with all our needs and decided that, yeah, why not? Claude Sonnet 3.5 works for us. It can understand images of documents and can produce HTML code that quite good represents the document itself. And we went with that. But how did we actually do it? So that's our initial pipeline. We started with converting everything to PDF because PDF is very flexible. You can do whatever. And each page from the PDF was converted to an image file. And each page was sent to the LLM with an instruction or prompt to convert it to HTML, but not any kind of HTML. Like very simple, with specific extra attributes so that we can parse it later. We created a programmatic way to parse HTML to our own internal model. And we created PandaDoc templates with that. It worked, but it wasn't fast. Like documents can have tens or hundreds of pages. And when you go in sequence, one after one, it will take forever to convert. So we needed to go parallel. That's easy, right? So just map, reduce, combine, and voila. Turns out that's not your only problem. LLMs make mistakes. LLM APIs are not available all the time. So we needed something else to orchestrate that process. We introduced temporal. I don't know if you heard about it, but if you didn't, read up on it. It allowed us to go parallel very easily. It allowed us to retry on errors and handle gracefully those. And yeah, speed improvement. 3 times for average 6-page document. But the reliability, that was the key. We had so many problems initially and it just smoothed it out. So I strongly recommend you use it. What we did next, we had our initial prompt to convert, but it wasn't great. It did kind of a job. But we needed more. We needed to get into prompt engineering. And how did we do it? We followed some online materials. We created this huge prompt that guides how the LLM should think about the conversion. So not only give me this and that, but multi-step process. First, analyze the document structure. Next, analyze each block styling, and then apply some extra rules to finalize it and stitch together the output. We also used XML-like structure because our model, Cloud Sonnet, very much likes it. Your experience may vary, but Cloud likes it. ChatGPT doesn't really. It's much better in understanding Markdown. So just read up on your provider's good practices or guidelines. Important thing, examples. Without examples, the LLM will think about what it was taught about, and it learned a lot of stuff from internet, and it's not always what you want. We wanted specific syntax, specific output, so a lot of examples. The prompt ballooned to 1,500 lines, but it did the job. Yeah, go Google best practices for your provider. So we had something working. We deployed it to production, allowed some portion of users to use it, but real life happened. Not all kinds of documents were nicely converted. What to do next? How about we only convert those that look that we will be able to easily convert it? We introduced a classification step before. We picked some categories that worked best, like plain text documents, contracts, and strongly rejected, like graphics heavy, brochures and stuff like that. So we improved customer satisfaction a lot with just simple classification step. But what else? We had a problem with LLM hallucinating content, skipping parts of the content of document. So we introduced the classic step, OCR the page, provide reference implementation to the LLM and ask it to recreate with our own rules. It fixed a lot of issues, like for real. So I recommend you investigate classic approach and see if you can use both at the same time. And one more thing, turns out even plain text documents have some images in them, like company logo, maybe a signature, something that cannot be represented with text. So we quickly added an extraction of assets that improved, again, satisfaction a lot. But what's next? How do we know that any of those changes actually impacted the quality of conversion? Introducing evals. We created a curated dataset of documents with a reference implementation of them in HTML, and we run them, the PDFs, through our converter pipeline, and use another LLM as a judge to tell if that conversion is good or bad or something in between. It allows us to actually tell if the changes we are making to the prompt, to the pipeline, actually do something. And if you used LLMs ever, you know the output, even though you specify temperature to 0, can vary. Like the same model in the morning will produce something different than in the evening. So really, if you introduce LLM once, you have to use it everywhere. You cannot compare like text, character by character, or even picture, pixel by pixel. So that's beginning of our prompt for a judge. You can find some references online how to do it. I recommend you keep this short, because the longer it is, the LLM gets more confused. And fun fact, if you ask it to provide a score or a grade first, an explanation later, it will be a terrible judge. If you do it opposite way, it works nicely. Why? I don't know, it just is. And one more thing we needed to check before going general availability, the cost. You know, LLMs aren't cheap. And we realized that when one of the customers uploaded 600 pages document, and we spent like $20 on one document. And yeah, limits are nice and cost monitoring is nice. So go do it. Also, caching is available, so investigate that. So what did we learn in that process? From engineering, not that easy, even when another LLM helps you. We use that too. Like when you analyze the results from evals, you can ask, what's the most common problem? How can I fix it? It will propose you do some changes to your prompt, and the changes are terrible. And you iterate again, and again, and again. LLMs make mistakes. One slide after that will be about that. So I'll skip for now. AI APIs are unreliable. Yeah, we have a long list in Sentry of what's happening when you call LLMs at scale. They produce all kinds of errors. So be prepared, use some LLM router, retries and stuff, because you'll run into a lot of things. Again, temporal, read Appotent. It pairs with AI very nicely. Allows you to run long running tasks efficiently, at scale, reliably. Interesting lessons. Users might not like your new features, especially with AI. Not everything needs AI. We introduced the classification step because the AI wasn't good at everything. So consider that maybe the thing you are doing is not needed for everyone. Real documents are messy. Yeah, when we released it initially and our internal users were using it, everything was fine. But when real customers started uploading files, we started to see some crazy formats and crazy content. We even ran into content filtering policies in LLMs because they really don't want to talk about some subjects. And in documents, you can have some subjects. So be prepared. Not everything can go through LLM. And again, token caching, important. That's a nice example of one of the problems we encountered. That's a screenshot from a document, actually from the output of a document. LLMs, when you ask them to create 100 dots, they will happily do it. But often they create more, thousands. They will run out of output and just crash. So be prepared. JSONs can be incomplete. You have to have fallbacks. So yeah, that's the first point, getting stuck in a loop. We ran into fun issue before we introduce the OCR step. The LLMs can be paraphrasing the output from the image you want them to recreate. Like there is some clause, but the LLM learned that this clause happens in a bit different format somewhere in the web, and it will paraphrase. So that's weird, but that's just what can happen. Be prepared. Of course, skipping parts of documents, why not? Hallucinating, that's always fun. And yeah, content filtering policy. If you have huge document and some pages didn't process, what do? You have to be prepared. And that's pretty much it. So we deployed the solution. At the moment, almost half of the PandaDoc users can use it. We increased the satisfaction with import. It works, but we plan some changes regarding the architecture, improvements to quality, to speed. A lot will be done from now, but yeah, these are our lessons. That document conversion is not just conversion, it's a lot more, and it involves everything from like business relations to infrastructure. It's been fun to implement this. Another lesson is that LMs are powerful, but they make mistakes, and you have to be prepared. Like really, you have to account that they will make mistakes. You cannot make them perfect, and you have to somehow live with that. And yeah, we use LLMs for a lot of things. So it has been fun for me managing a fleet of LLMs in different roles. We had Converter. we had Judge, we had the results analyzer, you have the advisor in your editor, you have LLMs producing your Jira tickets, you have LLMs reading your Jira tickets. It's like, do I even work with people anymore? But yeah, that's all. Thanks.
Okay, so we will proceed with the Q&A. We'll start from the first question. How about content which spread between pages?
That's a very good question. We have very basic merge mechanism that if something is detected as being continued between the pages, we'll stitch it together, like lists or paragraphs. But for example, we didn't do it for tables because tables start again on the new page. So you have to figure it out. But it turns out simple stitching works.
Okay. Let's go to the next one. Have you tried layout focused OCR?
Yeah, we did that, but out of the box, it produced bad results. Like OCR will detect the outline of text of paragraph, so we'll tell you bounding box of it, but to position it on a page correctly, like with margins or inside the table, it was not great. We are still investigating hybrid solutions, and my personal hope is that that will be better than just sending whole pages to LLM, but it's still in the experiment phase.
I think for this OCR solutions, basically, if you ever tried docklink or marker, right? So this is basically, well, there are different ways how you can really read PDF and convert PDFs into some sort of a text. Like very simple one, you just read whatever spits out from the PDF, like you convert this to the text. Obviously, it's going to be terrible because the way how the PDFs are structured, like this is a print format, right? And so all those simple tools, they semantically do not understand how it's like laid out on the page, because it can be 2-column layout, it can be an image with the some sort of like a description or something, right? And the problem is like if you use like very simple converters, like you lose all the layout, like layout structure. And what's important for PandaDoc, like when somebody comes and drops the file, they expect it looks exactly like this. And what exactly like this means is layout, styles, alignment. You know, like sure, you can use more sophisticated markdown libraries like docklink or marker or some other, right? Even some like on the top of LLMs. And what they do is like they use the layout-based models, like as Shimon said, like it just basically puts the layout out there, like semantically look at the layout and then convert those boxes into markdown to keep it semantically correct together, right? It's not like an image in one place and then description of the image somewhere else, right? But the problem with this approach is like it also misses all the graphic information, like styles, right? So in Markdown, you don't have like a text alignment or like a merge cells in the table or like something else. And even if you perfectly convert this into Markdown, it's still not going to help you. But I think like the way how we do this right now is like just the LLM looks at the page and converts and extract all this information, and it's just much easier for us to start. But as Shimon said, like we're gonna experiment with this layout based, and we can feed the parts of the image to LLM to do this this work. And the main reason why is because Shimon mentioned this is like 1,500 lines of prompt. Guess what's happening if you change one line? Well, it might break in completely different place, right? And so what's happening with the prompt is like prompt erosion and context erosion because of this. And if you can like narrow this down to only like a table, have instruction to convert table, you have a better chance that the LLM actually will do a better job. And then for the text, you also need only instruction for text. So that's what when Shimon mentioned like the hybrid approach, that's kind of like where we are going. It's not going to be OCR, but it's going to be a layout-based LLM conversion, I guess. Yeah. Layout detection.
Okay, next question. Did you encounter documents that resulted in incorrect OCR extraction? How did you check for content hallucination in such docs?
Yeah, we tested a couple of different OCR tools, and for example, Tesseract produced very shitty results. Like for two column layout, it decided like every line is just everything, right? So some of the issues we caught just manually testing the tools. We also ran a small batch with LLM as a judge. Convert, see what LLM thinks about it, right? Like 15 documents. What we are doing, we're using now DocLink as OCR tool. It was flawless. So no more issues right now. But we don't know. Maybe we'll find some edge cases.
Okay, the next one is, did you publish any metrics of your solution? Did you publish any benchmarks?
We have some benchmarks based on our evals. Like we are aiming for 70-80% accuracy in conversion. So each document has some issues, but they are minimal. We strongly penalize breaking things, like when text was cut or hallucinated or something. So we are very cautious about that. In terms of performance metrics, benchmarks, we monitor it live. Right now, it takes about up to a minute, like 40 seconds, to convert any document. So we want to improve it a lot, but the main bottleneck is the LLM itself. The call takes like 30 seconds because the prompt is huge, because the image is quite high quality. Like we experimented with different DPI settings for the image export, but the less you give to LLM, the worse results you get. So try different things.
Okay.
Another problem is like, there are no really solution we can compare it to, because like nobody actually convert the document into like a format which preserves the layout and styling. So there was a question about did you use the PDF to HTML, I think, right? So the way how the PDF to HTML works is, if I remember correctly, so there are different kind of like ways how you do this, but some converters work, they look at the layout and they basically reconstruct this with the absolutely positioned divs, like 2 points, sometimes they go down to a symbol to be able to preserve the layout of the PDF. Again, because the PDF was a print format, like it was invented for this, right? So it's absolutely positioned. Now, it's not going to help you, because if you have like 15,000 divs like position, it's going to look exactly like PDF, but it's not going to help you semantically parse this content and lay down this in a different format like HTML. Now, there is another approach, is like sometimes they basically convert this into like HTML, but this HTML in many cases is not representative to what you see in the PDF. So it's kind of like challenging. Now, going back to the metrics, like there is no solution we can compare, say, oh, like ours is like 10% better or faster, whatever, right? Because we can compare this to the Markdown conversion because it's completely different.
Okay, next question. Any privacy concerns for using LLM providers?
Of course. Sergey, maybe you'll answer that.
I mean, yes, there are concerns, but I think we should learn how to live with those concerns, because LLMs are not going anywhere. But like jokes aside, is when you're going to use the state-of-the-art providers, right? And you will use state-of-the-art providers, like there are different ways how you can eliminate this legal risk, because we're all using like AWS or Google Cloud. It's the same thing. They have access to your data, right? And so when you work with the state-of-the-art LM models providers, like basically the way how you can eliminate those risks is like having and controlling the way how they can control your data. Meaning the zero data retention policy on your providers, like contract obligations, the way like the disclosure of your information, opt out from all the usage of your information for the training purposes. Is it 100% like prevents everything? I don't think so. Yeah, but like it's kind of like a reality right now. Like that's exactly how if you use any other data provider you send data to, it's the same thing. Same thing, right? So I think right now like it's a lot of like this is a very sensitive topic because well technically providers can use this content to train the models on top of this. Like you can opt out of this, like we don't know like if it helps or not, right? And for really, really sensitive things, like for example, when we're like extracting data or like doing some stuff like on the scale with a document where we don't really want to send content to, I'll talk about this like in the next presentation a little bit, like we try to use open source models and where we can. And the reason why, because like we can control the access to our data and we can control how we consume this. Like we tried a couple, like Llama models 5.4, like some other things, like for the classification and extraction. And for those things, like we probably will prefer the local models just because of this.
Okay, let's move to the next one. In your DocMorph pipeline, why did you decide to convert PDF pages into images before feeding them into LLMs?
Simple answer. Context, window, and attention span. When we even try to converting 2 or 3 pages at the same time, LLMs just get lost. So we decided the best results, even though you don't have the context of where the page is, we decided to go page by page. It works better.
Technically, you can send the page of the PDF, right? Not an image. But the problem is like we don't really know how the LLM consumes this PDF page. Because what's going to happen, like what might happen under the hood, like it can use the same PDF to markdown type of library, get the content out of the PDF. But like what we need is actually preserve the layout and the styling. And that's why image. That's why it's VLM, right?
Also, there is a typically limit to how much data you can send to LLM. For Claude models, it was 8 megabytes or something like that. It's a couple of pages of scanned document.
Okay, now the question about business part. Why PandaDoc is better than other popular tools, and how much does a monthly subscription cost?
Well, look, we're hiring, and if you join PandaDoc, you get a free subscription. So if you're a developer and want to use PandaDoc, find our recruiters over there. But jokes aside, you can go to pandadoc.com. There is a pricing page there. I don't remember, like it's 19, like 39, something like that, 59, depending on the plan, depending on the features included. And why PandaDoc is better than the other tools? So our vision is like all in one platform. And what it means is like you don't need to jump between the tools to do the whole workflow. What I mean by this is, for example, so you have a document, you send this to your customer. So, and you need to tweak and edit a little bit of the document and then send this to the customers, and you need to change the pricing, you need to get the signature from this, and you need to collect the payment. Sure, you can use 3 tools. You can use your Word, upload to whatever signature provider, send it for signature, then collect and then send invoice, or you can do this in one place. And it's kind of like the main selling point that everything is stitched together and integrated. There are a bunch of customers here. I can ask them over there.
The next question. Do you use AI to create templates or documents from scratch? I'm an entrepreneur and I want to write a prompt in PandaDoc app and get a document proposal.
It's in pipeline.
Let's move to the next one. How you were evaluating quality? Have you tried converting HTML PDF just to test the PDF to HTML parser?
The problem is we want to really test the whole pipeline with the conversion from HTML to PandaDoc and how the PandaDoc renders that. So that's how you get like actual results. And have you tried converting HTML to PDF? Yeah, no.
Yeah, we kind of like you talked about the evaluations, right?
Yeah. So yeah, we didn't just test that part because why? We tested the whole pipeline because the prompt and the parser itself are kind of tied together. We expect some HTML structure so that we can recreate Pandadoc blocks in a standard way, in a way that the user would create them, so they are easy to edit. And we care about that a lot. If we only test back and forth conversion, then we would be using the standard tools and the absolute positioning thing.
Okay. Do you recognize charts and content from it?
Yes. As one of the last steps, we added recognition of images and extraction of them from the images, from the page images. It works surprisingly good. Like we had little problems with it. So yeah, if you have a chart or a logo or small image, it will just be imported as image block to Pandadoc.
Okay, it looks time's up. So if you want to ask questions, do it during the break. And now we'll move to the break. So give a big applause for the speakers. So the next presentation will be from features to platform, integrating Gen AI into PandaDoc, and the speakers will be Vadzim Shender and Sergey Baryshuk.
Very good. Thank you. So yeah, we slowly start moving into our next talk, and it's going to be about the platform. But before we start, just to kind of like size the audience, like how many of you guys developed agents? Okay, very good. And so why I ask this, because like you obviously can go and read tons of tutorials on the on web, right? Build your agent, and it's gonna work. Now the problem is like when you start scaling this, and when you start really applying this in real life, it's a slightly different story. And this different story, it's not coming only from the way how you like work with LLMs, or the way how you code your agents. It's also coming from a structure of your company, because if you have many developers that develop many agents, right? And so this story is actually about this. It's going to be a mix between kind of like organization, architecture, and the technical approach, the way technical approach we took in PandaDoc to build the agentic layer. Now, I'm together with my dear friend Vadim. He's going to be talking about all the technical aspects because he built this. I'm just talking about general stuff, right? So he knows. And myself, I'm CTO, and Vadim is principal engineer, like with PandaDoc, more than 10 years, like knows everything. Shimon talked about PandaDoc a little bit. So I added a couple more facts here, which guide us to the decision and to the need to actually approach this slightly different than just building something like hacky solution. And those couple numbers is like we process like 50, not process, we send 50 million documents per year. Like, which means like we're talking about hundreds of millions of documents of our customers. And if we want to apply AI there, it's a different story from cost, scalability, and all the issues like along the way perspective. Moreover, we have 300 people R&D organization, and we want to grow even more, so we're hiring. And if you're a developer interested, go and find our recruiters over there. But what it converts into is we have 40 product teams, and obviously everyone wants to build AI, right? Now guess what's going to happen if everyone is going to be building AI? It's going to be a lot of AI. And so our application is also pretty complex. Like if you think about this, like on the surface it seems, yeah, sure, you know, like just e-signature slap on top of the document. But so we handle, as I said, like we're all in one. So we handle document editing, which is a domain in itself, like super complex. We're handling payments, we're handling CPQ and quotes, and your catalog, we're handling integration, just like tons of things, which actually makes the whole product, which also impacts the way how we actually think about AI. Because if you think about like different domains and different teams using AI, like we kind of like need some consistency across of this. All right, I'm gonna share one video here. Don't tell anyone about this. It's not announced yet, but I think it will help you to understand what kind of we're building in PandaDoc from AI perspective. So everything else afterwards will make sense, okay? Again, don't share with anyone web stream, but. I'm kidding.
Today, business moves faster than ever before, but deals don't wait because every lost hour means a lost opportunity. PandaDoc changes that with Agreements Hub, centralizing every agreement in one place, where agreement terms are auto-extracted. For instance, just ask the AI to show all your expiring agreements. Oh, here they are. Get emails of all the signers and send them a reminder. Organize your existing files. Just let AI handle the routine work for you, from finding documents to managing complex workflows. Does manual work steal focus from what matters? Drop in a file and it transforms instantly into a polished professional document. first word to final agreement, the flow is simple and automated. All with natural language commands. From give me a summary to organize everything for me. Yesterday's complex workflows are now simple asks. One consistent experience everywhere you go. Meet PandaDoc Agreement Hub.
That's where we're heading to, and it's just not to brag about this, but like for you guys to understand, like if you watch the video, like you saw that this AI is actually applied across the app. Catalog, this documents, in the editing. It's all going to be relevant like throughout the presentation. Anyway, let's go to the next slide. Well, when we started thinking about the AI, again, there's a lot of hype, right? Sure, like integrate AI, buy a domain.ai, and you have tripled your valuation, right? The way how we think about the AI is kind of like a tool, and I think the document automation is the perfect place where you can really apply AI and it's going to be useful. And there are three buckets, like how I think and the PandaDoc thinks about the AI is like how can we simplify the life and the job of our customers. Number one is they do a tons of routine operations like manual stuff. What Shimon showed you is actually manual. So what customers do is they open a PDF and recreate this document in PandaDoc. Like, how do you think? Like they like it? They don't, right? Like ideally, it should work automatically. Or another example for you, which we actually launched as the very first feature, is the document organization. So when we look at the data, we actually learn that the customers move files a lot, like in folders. Like we see this on the back end, like in the events, like, oh, what is happening? So they organize the files. So we started talking to customers, and so customers like, yeah, sure, like we created a Python script, which is like every 3 months, move our files like around, like renames them, like, oh, that's interesting. So this is type of manual operations I'm talking about throughout the application. Second, like we work with SMBs, and SMBs, those are small companies. Like we have customers here, like, and they use PandaDoc, and it's just like one team like one person operations, like 10 people, 20 people. So in many cases, they don't really have like all the resources that larger companies can apply, like a legal review. You don't need super sophisticated legal review, right? You need a legal check, like does it make sense or not? Or like rewrite my document and a copywriter, like who can come, like and then tweak your document, or like a designer, right? But with the Gen AI, you can actually apply this and help them. So you can really make these experiences like much better and they give much more value. And last but not least, like we work with the documents. So 50 million documents, obviously on the scale, like there are a lot of insights trapped in the document. Now, if we can grab those insights and kind of elevate and return them for you, like it's useful, like so you won't miss the renewal of your document. You can compare the documents, you can find them easily. You can ask like, hey, what is my total value of all the contracts we closed in France last, I don't know why France, but like in France last year, right? And it's gonna give you an answer. Now imagine like how much time you would actually spend on this, downloading the document, extracting this information. Like it's just tons of time wasted. So what I'm trying to say here is like AI is not for hype. Like AI is actually a tool which can solve tons of problems for our customers. Now, story beginning in January, obviously it was like upcoming wave and like a lot of things happening with the AI. So we decided to invest and we built like a little team, a small team, like 6 people, like 5 people maybe. I don't remember how many, but like small team. And so we started thinking about AI and how we can apply this in a consistent way, right? And so we started with the 2 principles in mind. Number one is, so even if we think about a platform, about like AI overall in PandaDoc, we're gonna go and build customer-facing solutions because you can't build a platform in the isolation. Like you need to try it yourself and really kind of like give it a birth, like through this. Because otherwise it's going to be isolated and it's going to be an ivory, like tower. like you design something like perfectly. And second, we understood that since we have like 250 engineers, 250 microservices, like everyone is going to be building this, like we can do a hacky approach because like it's going to cost us more, and all the people are going to reinvent all the wheels all the time. So we immediately knew that we want to empower all those teams later on to build on top of this, and platform is the way to go. Kind of like two main things here. So. And we began with a couple of use cases. Document Organizer is one of them. It was the first agentic experience like we launched. It's like where you come and say, hey, can you put all my proposals into this folder, split this into year and quarter, and rename them with the customer name in the file, and tag me proposals with more than $10,000 in one prompt, launch it, done, right? And we're like, oh, that's cool. It's kind of cool, it works. So, and then we kind of started thinking about, okay, so applying AI across the PandaDoc, and we came to a conclusion that there are three modes of flavors of AI, the way how you can apply it. Number one is hidden. I guess really hidden for the user. Like they don't really know about AI, it just works. This is a good example what Shimon showed, right? So when you upload a Convert document, you don't need to know like if it's AI or not, like it doesn't really matter, right? And but it just elevates this experience like for the user, and so you can get good results. Number two is contextual AI. This is not conversational or agentic flow, but something like you see in your email, where you go there and it's like, hey, you want to draft the email for you, and so there are a couple options. Like you click on the options, you get the email. There's no conversation involved, but there's an AI underneath, which will return you this email, right? Or something, I don't know, or build me a form based on this document. Boom, you get a form. Yeah, but user understand that this is AI underneath, but it's kind of like a one-button operation type of thing. And last but not least, like which you're all familiar with, because I guess you use ChatGPT and Claude and or whatever you like, and this is agentic flow, like conversational, and that's what you saw in a video, like where the user, like there's a conversation between the user and application. That's an agentic way. Now, like when we thought about this, is like great. Like how can we build all this stuff, and how we can really convert and layer this into a platform so we enable all the teams to build all those flavors in a very consistent way. So that's when we started thinking about the platform. We called it Moso, and just disclaimer, like when you see some of those names, and I hate this, like from some presentations, like, oh, that's cool, like I'll go, maybe it's open source. No, it's the internal name, just cool name. And so don't look this online, it's not available, it's just an internal project name, but that's how we refer to this. And so Moso is actually a fast-growing bamboo, which pandas eat. So therefore, it's Moso. Anyway, so we started thinking about the platform, and so when we deconstructed everything, so we understood that there are actually like 4 layers we need to build and provide to our teams to build on top of, which covers all these flavors of the AI and everything what we really want to do. Number one is, we call it Abyss, also internal name, don't look at Abyss, it's a data layer. So, and I'll talk about them like on the future slides, but it's kind of like 4-layer type of architecture. First, Abyss, like all the data layer. And one of the reasons, because in order to make AI work, you need to have access to data. And unfortunately, what kind of data access you have usually is not enough for AI, because the way how you expose this is different. I'll show you in a second an example. Then infrastructure, we wanted to eliminate all this need for you to really reinvent the wheel on the infrastructural level, router, everything. And then the layer itself and runtime for the agents. And next is the way how it's really exposed for the users and the way how they consume this, like user experience, right? Now let's talk about each of the layers, like really quickly. Abyss is the data layer. So you can think about this like 2 things it does. Number one, it processes the data. So use case for this is, for example, recently we launched a data pipeline which processes all our templates of the documents and classifies them. Like, why do we need them? Because we can elevate the user experience by looking at the the template, and if it's, for example, invoice, we can suggest something to them, or we can extract the specific information from the invoice. If it's a contract, then we can also suggest some and extract specific information. Now, the problem is like we have a couple millions templates, right? And how can we do this? So basically, Abyss is the place where we run those data pipelines. Those are all temporal data pipelines. Kind of orchestrate this and optimize the hell out of this because it's a huge load and a lot of data. So for example, for this template classifications, we experimented tons like with the open source models and running them on the VLM, optimizing inference, batching, like all this stuff to be able to process within days, not weeks, right? So, and the more of this use cases we'll have, that's where they will reside. Abyss, that's where the scale will go, et cetera, et cetera. Now, another use case for Abyss is the way how we expose data. So another anecdote for you, like we build the agents and the agent help you to search documents. That's what you saw in the video. It's like, show all my documents, blah, blah, right? Now, we do have search, obviously, right? You can search for documents. And we have API for this, underlying API. But guess what's happened? Like, so when we build this API, we obviously build this for UI. So what do you have in UI? Well, you can search by name. Like there are a couple of filters in the search as well. You can apply them. But the way how the people search in agentic mode, it can be anything. They can write anything there. They can say, hey, can you show me all my documents which I send there, and there are 2 recipients and the documents are not completed them, right? No way. And so we started kind of like seeing these patterns, started like deconstructing those patterns and understood that, well, our search is not going to work. Our API is not going to work. Well, we need a different API which will work with all this data. Now, the problem is data. So when we start getting into the document data, like it's very complex and it's a different microservices, different databases, like all the different. Now you can need to pull this data, make sense out of this, like flatten out and put like a API on top of this data to be able to serve this, right? And that's what Abyss does. Not everything what I told you, like we're still building, but that's kind of like where it's heading. Now, the next layer is infrastructure. And the infrastructure, you can think about a couple things. Number one is routing to the different models. Well, you can't really work with one model. You will work with multiple models. We use different models for different tasks. You can share keys with your developers, and they will put them in an end file in the repository. It's not a good idea, because like when you gonna, like replace the key, like you'll need to, like update all the stuff, and then depending on the models, you also provide, like you need to tell like what kind of models available, and then you need do a bunch of things around the LLM, like a cost tracking or like thresholds and limits, rate limits, and all this stuff. So router gives you this ability to just expose the open AI-like API and serve all the different models, but then control this on the backend. So the developers don't even think about this. Second is observability. Like when you launch the agents, so we need to instrument all your agents with the observability, so you really see what is happening and you can catch all the errors and also learn and also improve. So at PandaDoc, we use OTel, like OpenTelemetry, like for all our microservices, like on top of Grafana, and with all the tracing and stuff. In addition to this, like we added length views for our agents to also trace all the calls to LLMs and everything related to LLMs, and we also have like error handling. We use Sentry historically, Python shop, but it's been great for us. And last but not least, evals, because if you, it's slightly different than the normal features, right? You can't really test, well, you can test it, wipe test it, right, wipe check. But, so you need to have like evals in order to check like how it works and compare like and be able to upgrade to the new models, etc., etc. Well, you can reinvent this wheel all the time and let developers to figure this out, or you can give them the tool set so they can just plug in tool set and run those evals. And so we used the Phoenix before this, and then now using length views for the stuff. The third layer is the agentic layer. I'm not going to spend tons of time. That's exactly what Vadim is going to be talking about, like on the technical level. But this is the runtime which actually runs all the agents, right? So all the agents like can access tools, like all the authentication, all the context management, all the message history, like everything what you saw there, it's kind of like the runtime for those agents. You can probably guess then we have more than one agent, right? But it's a little like spoiler to your part, right? That's where the agents run. And last but not least is user experience. Again, based on the experience at PandaDoc, we know that if you don't really set the guardrails and you don't really have like a structure, people will go and build stuff. It's gonna look amazing, but it's gonna all be different, like in a different places. Lots of pop-ups, like this button, you know. And so in the very beginning, so what we did is like we actually introduced the guardrails, or you can think about this as rules, how you really integrate this. Like everything from the chat experience, the way how it integrates into PandaDoc, like the entry points, the experience, the responses. Again, because we wanted to provide these things as build components for our developers that don't need to reinvent the wheel, right? And so this is very similar to what you see in the Vercel AI SDK and just recently launched OpenAI following us, right? Like it's very similar. They launched the chat kit a couple days ago. Similar idea. Alrighty, and now we're switching, just cutting the agent, and we'll look inside, and Vadim will tell you how we actually build them. It's going to be more technical part.
Hello, guys. So I'm going to elaborate a little on how our agents work, how to build them, and before I do that, I want to step out and a little elaborate on the context in which we made our decisions. And the first one, as Sergey said, we want to build a platform, and it means that we want to solve as many problems as we can. So users can implement their agents without needing to think about observability. I mean, implement this on their own and other stuff that we can do for them. Another one is that we never ever built AI platform, and frankly speaking, very few companies have. So we don't know how to do this. We experimenting a lot. We learning a lot. And it's really important for us to make this experimenting really easy, because we encourage our teams, we encourage our AI platform teams to experiment a lot and to understand what works, what doesn't work. And the third thing, Sergey already mentioned it, that we don't build our platform in vacuum. So we are starting with building real AI features, and we distill our platform for this real product experience. So some of these components are platform for the first one day. It's mainly infrastructure, observability, logging, monitoring, AI agent, AI gateway, but other things emerged as patterns. So some feature proves itself, and then we generalize it as some general functionality. Okay, let's move to the next slide. So Sergey already mentioned that our platform is leveled, and you can operate on any of these levels. So the first level is infrastructure, and it includes some infrastructure that we don't want other teams to rebuild from scratch. And behind this infrastructure, we have other layers, and each layer is more abstract, more opinionated, and implements some specific features. But you can operate on any of these layers. So, for example, if you need some kind of chat experience, you can use this AI assistant. If it doesn't fit your needs, you can drop down to the agentic engine or even to the infrastructure. Because we experiment a lot, now we don't cover all cases, and we allow other teams to operate on any of these levels. And the next level after our infrastructure is our agentic engine, and it's actually how we run agents. And the first decision that we made here is that all agents run inside a single service. Not in single instance, but in single service. It allows us on these early stages to experiment more fast, to control everything. In future, we are going to allow other teams to implement agents in their code bases. It can be just declarative way to implement them. Maybe it will be a framework that will allow other teams to use our platform functionality and implement their agents on their side. But now, unfortunately, maybe, but we require to implement agents in our code base. It's a problem, but not a big, because we have modular system and everything is isolated. And here we can see code of simplest agent, and it's conceptually it's just instructions, tools, and structured input and output. It's parameterized by these classes. It's pretty similar to any lightweight framework that we may use, like OpenAI agents, Pydantic AI, I don't know, Google ADK. But our platform provides the rest. It provides modular serving, tracing observability, retries, timeouts, and also with a little of boilerplate code, it also expose this agent as nuts and points. And nuts is a message queue that we historically use as a RPC transport between our services. So writing this code, you get this service, get this agent served by our service, and you can access it from any other service in our infrastructure. And one thing that, as I say, if you don't want to implement this in our service, you still can use infrastructure level and implement everything on your side. But okay, about agentic engine, we have two types of agents: one-shot and conversational agent. And one-shot agent is like something like fire and forget. It gets structured input, returns structured output, and that's it. And it's very useful for when you need some AI-based functionality to be part of some deterministic workflow. For example, our document organizer is the case. We have some deterministic logic to iterate through files, and this logic just calls our agent, which categorizes one specific document. Another one type is conversational, and conversational agent keeps the context of conversation. So it manages history, it can ask clarifying questions, it can, I don't know, call tools across all this conversation, and it's like agentic conversation, real conversation experience. And to support this, our platform provides storage for sessions, for messages, such functionality as compaction of this history in order to make this context less. And this conversational type of agents is actually basis for our AI assistant. And AI assistant is the next level in our platform. It's next level of abstraction. It's a specific case. It's not only about how we run agents, but is also how we embed these agents to our product with consistent user experience and with clear rules how we communicate with, how we integrate with this platform. And surprisingly, it's one of the main focuses for us, because a lot of different AI features actually reduce to this specific pattern. User wants to work this way. He just chats in place with what he's looking at right now. A lot of use cases are reduced to this case. And to implement this functionality, we provide this reusable chat component and a way to plug in this conversation agent to some context in which it operates. And let's discuss how it's implemented. So in order to implement this, we made a number of decisions. Not all these decisions maybe stay with us in months or 3, just experimenting, but I'll try to give a rationale behind these decisions. So the first thing is that we need to decide how to organize our agents. And there are two approaches here. The first one is larger and generalist agents with long, broad prompt, and this agent tries to solve a number of different tasks. And good example of this is developer tools like Cursor or Cloud Code. They have really huge prompts. They have really broad tools. I mean, tools that can solve different tasks. And another approach is small and focused agents. And when each agent tries to solve simple, small task. And we decide to go with the second approach, and reasons the following. The first one is domain complexity. Yes, writing code is not easy, but all these models were trained on this task I mean that they consume, this training process consume a lot of code, and they are really good at that. But in case of Pandoc, we still have a very complex domain, a lot of entities, a lot of business rules, and models don't know a lot about this. So it's really difficult to explain everything in a single prompt and all these cases. And also the number of tools, I expect that it will be like hundreds. And as you know, maybe language models work not very well that you provide a lot of tools. It's good 10, 20, and that's it. And we expect hundreds of tools. And it will highly increase probability of hallucinations. And we want to avoid this. The second reason is error cost. And if speaking about developing, writing code using this AI, we are developers, and we are naturally used to work with errors, with bugs. We make bugs, we fix bugs, we have guardrails like tests, we have linters, we have staging environments where we can test everything. But our customers work with real data, with real documents, with real contracts, and cost of error in this case much higher. Another reason is cost control. If you're using this large agent, it makes you to use most capable models, and these models expensive. And on our scale, we have tens, thousands of customers, and if we can solve some problem with cheaper, less capable, but we can solve some problem, we prefer this cheaper model. The same with latency. It's dialogue system, and we want to answer as fast as we can. And we also prefer if we can solve some task with more fast, less capable agent model. We also prefer it. And last but not least, ownership at scale. When we have a lot of small agents, it's much easier to own them by different 40 teams. Otherwise, we need to share ownership of single agents between teams. It's much more difficult. Okay, we sorted out this. And the next question, we have a lot of agents, and how to choose agent which will handle the specific user prompt in the chat. And there are two approaches here. The first one is centralized agent router. So we have a separate router, and all these agents, I call them domain agents, which solve specific problems. They don't know anything about each other, they just solve their problems. And this router agent knows about each of these agent. So it's actually a description field in the definition of this class. And when user prompts comes to the system, it goes to this router. The router analyzes it and chooses the agent to call and to handle this specific prompt. The upside of this is that each agent is focused still on one single task. The downside is that we have one additional LM hop per turn. Another approach is handoff. In this case, we don't have separated router, something like this, but each agent knows about all other agents. And actually, each agent solves two tasks. The first task is the main task, and the second is meta task, which sorry guys, task when if it can't handle user prompt, it needs to pass control to some other agent. It need to choose or maybe ask clarifying question, and it's also responsibility of each of these agents. And in this case, you potentially save this one LM hop because we only need it when we transfer control, but it makes agents less focused. And we chosen the first one because our agents focused, and it's really rare that when interaction with one single agent takes more than 1-2 steps. So usually this switch is pretty frequent, and we don't save a lot of latency, but we still have this complexity addition. So we decided to go with more simple agents. Okay, we also sorted this out, but we have another problem. So before we potentially had this problem with agent and a lot of tools to call. More than 20, it's a problem. But here we have the similar problem. We have this routing agent and a lot of agents to switch between. So we need to choose one, and if it can be potentially hundreds of these agents. But good news is problem is pretty naturally solved because we have different contexts. As I said, we embed this AI assistant in different places of our application. And we name this concept as user context. It describes in which place of system we are. And this context, I mean that each agent is working within the specific context. So for example, agent which works with folders can't work with catalog, I don't know. And we actually use it. So we register each agent in specific context, and we know in which context we're working now, and this limits sets of agents to choose from. And this user context determine agent context, which will pass to the agent and give agent information about entities user work with, etc. And how it looks in the code. We just have agent context class. It has name, it has context model, result model, and simple template to render this context. And this prompt will be injected to each of the agents which is registered in in this context. And to register conversational agent, we just need to use this decorator, and that's it. And context model and result models should be the same as in the context, because we expect that every agent will return results in the same format. And this is a full schema how our orchestration works. So we have entry points. We have two options. The first one is, as Sergey shown, it's like sidebar, and we have something user works with, and we have the sidebar. And this what something on the left side is actually the context. Another case is full screen mode. It's like ChatGPT or Claude. So we don't have explicit context. So in the first case, we already have context, we already have agent router and limited set of sub-agents we can choose from. In the second case, we don't have it, and we have this context manager. This context manager has some agent behind which analyzes user prompt and choose between different contexts. Which context is more fits this prompt most. And then the same. It defines the context, determines the context, and then goes to agent router. And this agent router decides which domain agent to choose and call it. And this context manager, yes, it's additional LM hops, but it happens only once. So when we decide that active context exists, we fix it, and all consequent prompts will be addressed to agent router. But agent router, imagine situation when I, for example, in folder and ask something about catalog. In this case, agent router can't figure out which document agent to choose, domain agent to choose. Okay, we hand off to context manager analyze prompt, and again reroutes to our agent router. There is also a situation when it can do this, because our AI functionality is still limited, and we have broad functionality, I mean, in PandaDoc. In this case, and also domain agent also, it's possible that it can cover some use case, and we don't know what to do. In this case, we have fallback mechanism, knowledge agent. And knowledge agent is actually kind of RAG system, and it performs search across our knowledge base. So it's the case when we have corresponding functionality, but it's not AI based. And in this case, we just provide instruction how to solve the problem needs of user manually. And knowledge agent do this using RAG techniques. Okay, let's move to the part of communication of our backend with frontend. So on the right side, you see this chat component. And what's interesting here, so when our agent working, he's streaming this thinking process. It's thinking, calling different tools, etc. Then after this reasoning process, it starts streaming. And it streams not only text, but also widgets. And we implemented it using the following features. First of all, we use server-side events to stream these updates. Second, we use structured output to mix markdown response with widgets. So it's actually just a JSON with message, widget name, widget data. So when you implement your widget or your agent, you can, okay, I need widget. It's just a part of prompt. You use structured output, use pedantic model to explain how it should look like. and it's just a prompt. Please, in this case, provide me a widget with these results. And on the front-end part, we use partial rendering. So even if only part of this response, this widget takes only part of the response, it still can render some information. It's also make this UX more smooth. And the last part is that we stream not only this answer, but also this agent events about what's happening, thinking process, waiting for results of tools, and etc. So it makes such a smooth user experience, which is similar to industrial standards. Last part about UI is that you don't need to re-implement this UI component. It's unified. It's ready to use. You just need to embed it. And all these things you want potentially configure is this widget system. And widget is just micro front end. We have widget registry. And when our component gets this, I need to render widget, it just find the corresponding micro front end by the name and renders it. That's it. Pretty simple. Last part about how we test it, how we more or less confident that we do the right things. And first thing is classical approach to testing. So this platform is not only about AI, it has some business logic. We try to use kind of clean architecture when this logic is isolated from agents, from infrastructure level. And we use unit tests to test all this stuff. We also use integration tests when we make real nuts calls, data stores in database. So it's usual tests, and all this faked, we use faked agents, faked tools, because we need deterministic behavior for our CI pipelines. But it's the first thing here. The second, Sergey already mentioned, is evals. And I encourage you to use evals as soon as possible, because without this, you can't really, I don't know, experiment and be confident in the results of your experiments. So to implement this, we use Enthuse. Before we used Phoenix. For each agent, we have golden data set with user prompts, with answers from tools, with expected result, and we use approach which is called LLM as a judge. And it allows us to be confident when we tweak prompts, when we change models, configure models. So I encourage you to use it. And the last one is like wipe check. So we call it wipe check. It's so you have tests, you have these evaluations, but when you develop and you want to experiment, it's really useful to have some kind of end-to-end experience. It allows you to feel this feeling, what your customer feel. And to do this, you need to introduce changes, to pass all checks, to deploy your changes to staging, to test it. And this feedback loop is pretty long. And also it breaks your flow state. So we decided to make a CLI tool, which is developer AI assistant, and it runs all our agents on your local machine, but still having access to tools in your staging and product environment. So you just can tweak prompt or change some business logic, rerun this tool, and give feedback right away. It maybe seems not so important, but it improves your experience as the developer in significant way. So you can stay in this flow state and deliver much faster. So if you developing something agentic, I don't know, I encourage you also, maybe not this way, but reduce this feedback loop as much as you can, because it helps you experiment a lot. And as I said, it's one of the most important things for us. We need to experiment a lot and give results as fast as possible. That's it from my side, maybe. And I return with. Yes, this tool is wipe coded. Yeah.
All right, so as you can see, we have a lot of stuff, and a lot of this stuff is coming from the fact that we have 250 people, 250 microservices. To deploy something, it's a pipeline, it's a bunch of things. You can't really install PandaDoc on your local machine and test something. It doesn't work like that, unfortunately, right? And so a lot of this is coming from this fact, is if we have like just one giant prompt, how can the developers actually contribute to this? how can we actually, like just make them more independent so they can move faster without breaking things and bumping into each other. All right, so the one thing we forgot to mention, I skimmed the question. There were questions like, can you open source this? Like, look, we forgot to mention that all this stuff is actually a compilation of the open source tools, like our agentic framework based on the OpenAI Agent SDK, which is not related to OpenAI. It's a generic SDK, but it's kind of like based on this. So we don't reinvent the wheel. Like a lot of the evals mentions, like the tracing, like it's all open source. Like the only thing which I think relevant for us is like, and what we did is like how we tied this into the context of the application, because you don't even think about this like when you use ChatGPT, because you have only one context. You have your window and your chat. Like with PandaDoc, when we started like doing this, and we put the sidebar next to it, we started seeing the questions like, hey, what is my documents in this folder? And we're like, which folder? Like AI doesn't know anything about this folder, because it will know about this only if it's within the context. Like, how can you pass the context? Sure, we implemented this. It started knowing about the folder. Guess what's happened next? User goes to catalog or somewhere and say, hey, can you like, what is my products in this? And we don't know anything about the product. So we decided to implement this context switching. So all this stuff coming from the fact that the way how the users really consume this app, right? And it's maybe relevant only for us. Maybe it's not really relevant for the rest of the world. Anyway, so we're still very early stage. 9 months in, we kind of like played with the technology for 3 months. We kind of like started building a platform really Q2 somewhere. So we had like some the very basic version, like somewhere around like end of Q2, and we implement a bunch of things. We push them blind into Q3. So we're moving really fast, but like it's pretty early. And a lot of the things what you mentioned, so we might really, I don't know, like we might change some things, like they might become irrelevant, right? And then, so what I wanted to say, like tons of things are still on the list, like a durable tool execution. So like tools will fail, API calls will fail, right? So temporal is the answer. Like we use it internally, like for many things, and it connects well, and you can build a durable tool execution on this. Like what I mean by durable is like retries, you know, like and thresholds, like all the things. Then for us, like what's important was also questions like, are you going to charge more? So the people will definitely abuse some people. So we need like a whole system, like the way how to protect this, like for us. And so we can do this like on the router side and say, hey, for this like LLM, for this, you know, like for the single session, like you can use this threshold. But we have, like, we need to connect this somehow with PandaDoc. Like, we have a different tiers. Like, we have enterprise subscription. We have, like, simple free subscriptions, you know, like, and then we need to apply this on the account, workspace, user level, which is relevant to PandaDoc only. So we kind of need to tie all this together, right? We need to integrate a lot of customer feedback. Even right now, like when we hunt for this, like this thumbs up, thumbs down. So if you don't use it, use it. Developers will appreciate you using this because they will know what doesn't work. So we really need to implement this to understand kind of like how to iterate and improve this. So we need the whole thing, like a product telemetry. Like people don't even think about this, right? Sure, like you can read the article and build the agent. The problem with the agents is like the way how you measure and track the agents is a completely different how you really track the products. Like the way how it works in the product, you have your analytics, you send the analytics event. User clicked on this, user did this, it was successful. And then you have like a build pipeline, the dashboard, which shows like how the features are used. Is different in the conversation because user can type anything in the message, right? But how can you look into this, like of what they use? Sure, you can go and look at the agents, or you can go and look at the tools as well, what they call, but you really can't look into the text until you instrument this on top of this and start fishing out as like, oh, actually our users asking agents to do this, but we don't do this. So maybe we should, right? The way how it works in the product. And so the whole thing, like Vadim was explaining this knowledge agent and this fallback. So that's what we learned as well. We had agents, right? So the document agent or whatever. And the user is asking like, send me a send a document. And so what agent does is like, it's like, okay, sure, like I'll send you a document. What's the recipient? Like you type a recipient, and agent like asks like, what, like some other questions, but we know that it can't send the document, right? So like it's just like hallucinating and asking your questions until it's like, oh, I can actually do this, right? Ask 5 questions. So what we started doing is like, we can teach our agent to tell no, right? I can do this. It's good, it works, it prevents this like bad negative experience, but also not very good for the customer, right? You can say no like and go home, right? Or you can say, hey, I can do this, but here's how you can do this in PandaDoc. Go to document, click send button, then enter your email and send. And so this knowledge agent is actually the agent built on top of all our knowledge base we have. Basically grab all this stuff, ragged this, created the rag, created the knowledge agent, created the fallback mechanism. So now when the agent is like, hey, I can do this, the fallback goes to knowledge agent, and knowledge agent, here's how you can do this in PandaDoc, right? And we'll also capture this feedback to track like what's really like not working. Kind of capture it, still early stage. All right, and the last slide here is we're actually, so we didn't mention this in the very beginning, like we made a deliberate choice that like we want to be within one service just because like it eliminates all the complexity. But I think there were like some people like laughing about the 250 microservices. Like we'll answer the question, but we have like a different teams and they move independently. So they have different schedule. They release like constantly. We have like 20, 30 push outs like every day. Like the product is moving really fast. And really on the scale, and that's what people don't really talk about. Like on the scale, you don't really want to slow them down to be in like one central place where everything is happening, right? Ideally, if the team is working on their like agent, which is plugged into the system, and the agent can do the stuff, but it's completely independent. You know, like it's a maybe settings, maybe quotes, maybe like catalog, maybe something else. They can develop this independently outside. And I think where we're heading to is like really have a system, decentralized system, with the registered for tools and for the agents. And kind of like from the different repositories, when the teams like deploy this, we pull this up and our system knows about all the agents because they're registered for the different contexts, the tools are registered, and we instrument them. So basically when every single time when the team pushes out the new update, we immediately pick it up and it works. You don't need to do anything, right? Same with the UI in the chat. Like they develop this micro front end on their side, they push this out, we recognize there's a registry, we pull this in, render, boom, you got it. So in this case, like they all moving independently while we're maintaining the central, you know, like user experience and everything. That's kind of what we wanted to talk about today. And that's it. Happy to answer any questions.
Okay, we have lots of questions, like 19 questions, but I hope that we will at least answer most of them.
Let's do it.
So the first one, what is the process of creating PandaDoc ads?
I don't understand this question. Like, did you like the ad? Ah, okay. We have a great designer, but I'm not gonna tell who is that. No, like, so you're our designer. Like, he created this. I have no idea how he did this. He just like guru. So.
Okay. Are you planning to open source your platform framework in the future?
I don't think so. Like there's not much to open source because again, like I kind of like answered these questions. Like we use OpenAI Agents SDK like for orchestrating, right? We use Temporal. So there's just very like small elements which we customize like for us, right? And that's what we're trying to, because we don't want to build a framework. Like we're not in the business of building framework, right? Zero desire. But at the same time, like what we learn, like when we experimented with the more established frameworks, obviously people use LangChain, Pydantic AI, like some other like frameworks. When we kind of like started integrating them into our like infrastructure, it's like, hey, Temporal should be here, we need to pass a context. So what we started seeing is like we're bumping into the places where we can't really override something, we need to rewrite something. And then at certain point when you rewrite this, like, maybe I don't need it, right? So we kind of opted in the very beginning for the super lightweight and thin kind of like shell around this to be able to control this. Is it the best choice? I don't know yet. So we might say sometime, maybe not. We'll see. But so far it works.
Okay, next one.
What our users?
I
It was like,
think-
what our users? Data science? No, we're no.
I think I will remove the question or not.
Then, but I answer like I read this. So our users is like businesses, SMBs. They use PandaDoc for. Okay, this is purely internal. And so basically, why we developed this platform to allow all our teams to build AI experiences. So for example, you're working with a document, right? Sooner or later, users come to you and say, hey, how can I edit my document in this chat assistant? Because like I don't want to really edit this like manually. And so what we want them to do is plug into this, write the agent, ideally with minimum efforts, right? Plug the tools, boom, and it works. So basically the users of the platform is all internal teams who are going to be building any AI experiences for PandaDoc app inside, not externally.
I just want to say that we use kind of domain-driven design approach, and all our services belongs to different domains. And if team, for example, document team or I don't know, billing team wants to implement some AI solution, it just implements on their side and owns it. So it's also answer to the next question. So you own these tools implementation because when you work with documents, you provide some tools to do something with documents. You own implementation of these tools, and you own agent implementation, prompts, structured input definition, etc. And we want all this stuff to belong to the corresponding services. That's it. So we don't have 250 services, no.
So, but yeah, so when you join PandaDoc, you automatically get assigned to the service. And if you're a senior developer, you get existing service. Like if you're a middle developer, you get a new one, so you can develop. And so the existing services, like we got you on the pager, on-call duty, immediately when you join this. No, it's a joke. I don't even know like if it's 250, like I just rounded the number. Probably not, right? 100? Oh, okay, slash it. Everyone gets 2 services. Okay.
Okay, let's move to the next one. Do you have plans to release something for just open ChatGPT store?
So 3 days ago, we did not have these plans, and now I think we do. Just discussed today. I think the world is moving so fast that it's just like it's so hard to keep up. And again, one of the like reasons for the platform is just like we want to just speed up the teams, like so they don't need to reinvent this. But the short answer to this, like yes, we want. I think it makes sense. 800 million weekly active users. It's a lot. It's a new distribution channel.
How do you check whether you've lost any files or important information when a user interacts with the AI?
Like, who posted this question? Like, is it in the audience? Can you clarify?
Yeah.
So we answer.
At the end, maybe
Can
I
you
will
clar-
go
Can
with
you clarify a little bit?
So I have an answer. So for example, it depends on the case. For example, in this case with document organizer, we just have a widget to show organizing results, and you can check and apply or reject or try to elaborate a little what's the problem you found and try to rerun this organization process. So it depends on the case, but usually it's like when you code in Cloud Code or something, Cursor, you check these diffs. And here you also check results and you can apply or not.
Yeah, I think it really depends on the use case. Like, I don't fully understand, like we can talk about this later, But so for the use case, like Vadim said, is like when you organize files, for example, so we render the widget which you visually see, okay, what is moving where, right? For the important operations, like we want to show this because like it's a very, how to say, kind of like break-in type of operation. Like you will move like 1,000 files somewhere, you know, like if it's incorrect. So we try to show this kind of like a user and let the user approve this. Like when you ask, for example, agent is like, look, summarize me a document. I mean, we'll summarize. Like, do we miss something? Like, we don't really know, right? And I think when we start working with this, like a qualitative feedback from the conversation, I think that's where evals can get into. But when we get into territory with the content and is it kind of like a correct, that's where it gets really complex because like there is no single answer, right?
And next one, any response resolution time goal for agents, aiming and concluding the result in 5-10 seconds or several minutes is not a problem?
It's a very good question. We just discussed this today. And obviously, when you have multiple agents, handoffs, and the orchestration, and the multiple LLMs calls, like that's where the latency stacks up, right? You call LLM just like hangs. Like for some reason, like you get the response like in 15 seconds. Like what we see, for example, on our side, that sometimes we get pretty bad latency on the responses from the LLM, like Markdown and JSON. Just like sometimes it's not good. And so for us, it's a problem because in this case, like it's conversational. It's the way how you talk to ChatGPT or Claude. Like it should be fast. And so when we first launched, not launched, kind of like we were testing this agent, so it was like a very like request response base. You make a request, it goes and do something on the back end, and here's the response. So for us, it's like what like spinning, like, and what felt like really, really slow. So what we started doing is like we introduce SSE and the agent events. So this like things is like, hey, I'm doing this, checking the folder, like doing this. That's what immediate, like we didn't change anything. It actually was working the same, but it felt much faster because like we started showing the feedback back to the user. Then like what we noticed is like when we start returning the markdown, like we wait for the whole markdown and then return. So then that's when we introduced streaming. So we started streaming things, right? And it's also much faster because like for user, like they start seeing the content immediately, they start reading. By the time they read, like we stream like bunch of stuff, right? It's kind of like feels much faster. Did we solve everything? No, like we need to probably look into optimizing some of the things. And I don't know, like maybe it's also working with the providers because like if it's on the provider side, for example, OpenAI, maybe it's a tiers like with the latency, you can go higher tier, it's going to be better latency. Maybe it's a Azure AI, OpenAI like models, maybe it's a different inference. No answer yet.
Okay, next questions. Another business question. What about cost? Do you
From
plan to limit the
customers.
number of requests per subscription, or should we expect price up in a few months?
No, you should not expect the price. Like, we don't know yet the answers. We don't know yet, but I think what we think about AI is inevitable that everyone is going to be using it. Well, if you don't want, you can, like, it's optional. But I think like, so we want to have an opportunity for our customers to really experience this, like, and if it works for them, awesome. So which means that we want to have like some sort of a tier where they can experience this, like, and if it's really working, you know, like they can pay. I don't know what's going to be this in terms of the price and in terms of the model. We haven't decided yet. And but for us, like we're very early stage, but it's not going to be bundled into the price, at least in any foreseeable future.
Short question. Any dedicated MCPs?
You mean PandaDoc MCP? There are two answers to this one question. Number one is if it's our MCP, we do have MCP. Like already, you can plug it, go, tell us if it works for you, like eager for feedback. So we do have this. So basically converted our API into MCP, and API is around like a file lists, document creation, like send, etc., etc. Now, there's another aspect to this question, because if you remember what Vadim was talking about the tools, right? And I was talking about the decentralizing. You can see a pattern there that if the teams are developing tools and developing agents, they can technically expose the tools as MCP with a centralized registry inside. It's an internal MCP, right? Now, we definitely think about this use case. We don't know if that's what we're going to be doing for a couple of reasons. Like, number one is like tools might be too connected to the agents that they don't need to be outside. Well, Vadim prefers like the MCP approach because like when it's more modular, we haven't decided honestly yet. But I think it's kind of like a good use case where you have a centralized registry and kind of hub where MCP plugs and then they're discoverable either agents. But again, I don't know if this is the pattern for us because I think that in some cases tools can be shared between agents, but in many cases tools are going to be specific to the agents. And there was a question about the, oh, this one. A good segue. Like, yeah, it's kind of like we kind of answered this is we could implement a lot of specific tools, but then in this case, you need to teach agent how to use those tools, what leads into a big long system prompt, which leads to all the teams contributing to this prompt, right? Which leads to the questions and problems because everyone is kind of like working with the same things, and it's like prompt is increasing like complexity, and the LLM start hallucinating, right? Now, another reason, it's kind of like my personal opinion. I don't know, like if you share or not. So with the tools, I think it's great for developers, right? Not really for the business user, if you think about this, because the problem is like if you have a tool, right, and a tool returns. I know, like we need to. I see, we need to finish it. But if the tool returns a JSON. For example, the tool can return a status of a document, right? It's going to return you a JSON. Now, it's up for an agent to format this information the way how the agent wants. But in order to control this, you need to provide a prompt to the agent how to really use this tool and like show the results. Now, guess what? Instruction process tool equals agent. And so basically, in many cases, like if you want to control the way how the tool is being used and how the output is presented, the tool is enough is not really enough, like in my opinion. So it's kind of like how I see this is, and we will see a lot of the usage of the tools like in developers, like tinkering, like I use myself, like I have like MCPs like here and there. I don't really see, I see it's going to be more like an agent to agent for the business users. Just like too much of the business logic and kind of like how you use them within. You think the same way? Yeah. Yes, he thinks the same way.
Okay, this one is answered. What is the most popular use case among PD users for the AI agent?
What is the document search and then follow up? So one of the use case which we discovered is we dumped all our usage data, and we categorized and aggregated this usage data by like what's used the most, events. Like this is a classic, the product analytics and all the stuff. And what we noticed is our users click document analytics. We have this feature when you send a document, we track analytics on a document, and we see how much time people spend on particular pages, how many times they open documents. It's really good because you understand like if they view this or not. And so what we learn is like they actually go to document and check this analytics and check the status of a document all the time. In order to do this, like they need like 3-4 clicks to go to the document, go to the analytics, like go to the specific person, look at this, go back, go to another, look at this, close the document, go to the next one. We're like, interesting. So basically we build an agent which can provide you a status summary of a document, who signed this, who hasn't signed this, did they view this, what the last time they viewed this, and suggest to do a follow-up action dependent on this. Like it's saying, hey, you also want to send a follow-up to this. Or if the document is expiring soon, it can tell you, hey, you want to extend the expiration. And so basically what we did then, we also integrated this AI functionality into our interface. When you go to a document, 3-dot menu, click menu, and you see activity. You search for a document, you see activity next to this. and people started really clicking on this button and getting this update without like all those clicks. I think this is kind of like one of the top use cases right now.
Okay, we have time only for one more question because pizza is already there.
So we have pizza.
It should be in a second. You have a large amount of data. Have you tried fine-tuning models for your specific task to get better results?
We did not. And so the reason why is, so with the fine tuning, it might work really well, but then you're kind of like a hostage of this fine tuned model, right? And when it's moving really, really fast, and so you fine tune the model based on, I don't know, like Llama 3, right? Then something is new, or like a new SOTA model is out, and you test this and it starts working better. It's kind of like you spend all this time and energy on the fine tuning for something which is irrelevant for in 3 months, for example, right? Now we have a very small team, like it's 250 engineers, like are working on the different things. Like on the AI, we have maybe 10 people, like working on this. So we can't really spend our time on the fine tuning models to get the marginal results. We just kind of like spend time on this. So the short answer is like, we have not yet. We might come to this, right? We're working on a couple of things, for example, around the documents of the document metadata extraction. So when you look at the document, you extract the key information from this, make it searchable, and make it like available for AI so you can ask really complex questions. And in some cases, like the fine-tuned models might work better, but we did not get into this. Like I think a lot can be done with the prompt engineering versus fine-tuning. Fine-tuning is the next step, and in many cases you don't even get to this because like you can do a lot with the prompt engineering.
Okay, so that was the last question. Additional questions later with the speakers directly, and now there will be a break for pizza, for networking. So enjoy, and once again, give a applause to our
Thank you
speakers.
very much. Thank you for coming.